I'm Dr. Paul Mason, and this is Mars in a nutshell. And we can see in this diagram how Mars might appear on a night. We could see that from night to night, the moon would move substantially in the sky. Here is May 21st, May 22nd, some particular year. We see the planet Saturn in the sky, Mars would be there, and the constellation Scorpius is here. There is a bright red star there, Antares. But Mars is also red and very bright sometimes. Mars changes its brightness substantially, whereas these stars would not, because as Mars orbits the sun, and the Earth orbits the sun, Mars can sometimes be relatively close to the Earth, and other times be much further, many times further away than others. So it can change in brightness. So we imagine here that Mars is seen at near opposition, and the full moon is here. That means Mars would be the brightest it is during any time over a course of a period of a couple of years. So the thing about Mars is that it became very interesting once telescopic observations began. Even back before photography, and Schiaparelli in 1888 drew drawings of Mars, and the photographs showed nothing like this. And in fact, as you looked at it, a lot of this was his imagination. Similarly, Percival Lowell had similar drawings, and even in 1906 there was an article in the New York Times declaring there is life on Mars because of these markings that he described as canals, which really were a misinterpretation or a mistranslation of Schiaparelli's canale in his drawing some time earlier. But really all of these drawings were really very much exaggerations or the imagination of some of these. But we can see that these very highly detailed images, modern images, show that Mars does go through a variety of transitions. So some of the people thought that this difference in discoloration that might be seen through even a small telescope over periods of time could be due to vegetation, but we know that is due to dust storms, and markings will change because of dust storms over time. So Mars begins to get interesting in terms of its study with missions, and some of the very earliest missions in interplanetary space travel were to Mars. The Mariner 4 mission was the first successful mission to fly by Mars, and it took these pictures that you can see some craters. Not much detail is seen here, but as a first attempt it was quite successful. Quite a few Mars missions failed, both Soviet Union and United States missions attempted, and about half of all missions to Mars have failed, and this has continued from the beginning up to even the present day. So one of the things that was noticed in this very successful Mariner 9 mission was that there were very strange markings on the surface that indicated water, or looked very reminiscent of water in dry areas on Earth where water had flowed. The Viking orbiter took this image, and we could see this gigantic marking across it, and we can look at some other images of that. We also see some volcanoes up here, and we'll look at close-up images of these. And so the Viking orbiter took this image. This is a mosaic from many, many images as it's orbiting around Mars. So again, we see a lot of detail that we associate with flowing of water. We see these kinds of islands that appear like a teardrop shapes, and water flowing here. Craters on top of areas that show past water erosion. So the water erosion occurred first. These impacts occurred more recently because any impacts that were there were washed away by the water before. Same thing here. We can see the kind of teardrop shape, and notice the scarp, which is the cliff along the edge of this island, is about 600 meters high. So there's enormous relief here in the image. And some other craters, the Bach crater, Lod crater, on some of these other features. Here is a Viking lander model showing really that it's not very large. It's on Earth with Carl Sagan. So a scene here is depicted to be kind of like Mars, but on Earth to give an idea of scale. Most of the missions are quite small, and there have been quite a number of different other things, because like rovers, this is Pathfinder, which let off this vehicle which was able to go roam and dig around separate from the lander itself. Topographic map shows volcanoes, and it shows this very large valley here, Valles Marineris, that we'll have a look at, and some other features. So this is on one side, and this is on the other side. All of the volcanoes are located in the high regions here, fairly nearby. The red indicates, this is topographic map, so it's not obviously not true color, it's height. So this is the lowest, the blue is the lowest, and the red is the highest, with these peaks as being the very highest. If we look at Olympus Mons, this is the largest mountain, it's the largest volcano in the entire solar system, dramatically larger than, say, Mount Everest or the any volcanic mountains on Earth. Valles Marineris, the huge streak which cuts across Mars, much across the face of Mars, is seen here with the Mars Odyssey program, and an infrared image that can show lots of details. There's a lot of depth here. The Grand Canyon would be a small feature in one of these side portions. This is much larger than the Grand Canyon. In fact, this would cut across the entire United States if it were here on Earth. So I can't go into a lot of details, but rovers have driven around Mars for several years, many years, and sit back data. Some are still there, or they're all still there, but some are still operating and taking lots of pictures. The Phoenix lander did for ice, found it, and in the northern regions, northern latitudes of Mars, had an ability to dig a hole down and found ice there. And this is water ice in this case. It evaporated away soon after. The Hubble Space Telescope had provided with excellent images. We can see that sometimes Mars shows clouds, and these are thin clouds. Mars has a very thin atmosphere of carbon dioxide. Mars does not have a strong magnetic field. It has a polar caps at the north and south poles. It has lots of craters, except where the craters have been washed away by water in the distant past. The MAVEN mission sent to Mars looked for what happens when solar flares and activity on the sun, and how it can affect the gases that might be released from the atmosphere of Mars. And sure enough, they found that hydrogen and oxygen are being lost from the atmosphere of Mars. And so, in fact, a solar storm caused and this is September 2017, and a solar storm caused the whole planet to have an aurora. This shows the rotation of the planet at the time here. This shows the observation from the MAVEN spacecraft that caught right along the edge a very bright aurora, not at the poles because Mars doesn't have a strong magnetic field, doesn't have a global magnetic field, but all around the surface, all around the atmosphere, an aurora, and there was significant loss of gas from the atmosphere. So over time, over the history of the solar system, Mars has lost a substantial amount of gas in a very similar way, and it was observed here with the MAVEN spacecraft.